So yesterday we have finished up to the measurement model. So today we are going to study, I mean going to report the structural model analysis. So in the structural model, what do we need to do? We have to prepare this table, right? This table, result of hypothesis testing. So they have 5 hypotheses, and let me check what are the hypotheses we have. Okay, this is our model. This is our model. So we have probably, I imagine that we have 1, 2, 3, 4, 4 relationship here, right? So maximum 4 hypotheses we can develop for this model only, okay? For this model, not for the paper. For this model, we have maximum 1, 2, 3, 4 hypotheses. Okay. So as an example, we have said that if top management, if there is a top management support, it will have a positive impact on the adoption of cloud computing. Okay, so that's the hypothesis we have developed. Now we have collected data and we want to test whether my hypothesis is supported by the data. Okay, so we want to replicate the table, right? Okay, let's draw the table first. Okay, so we have hypothesis, we have relationship, we have standard beta, standard error, beta coefficient, standard error, t-value decision. Okay, t-value. And let's say 95%. Then decision. I have R square, Q square. R square. Okay, this is square, Q square. And we have F square. Okay. These are the square, R square, Q square, and F square. Okay. So for the hypothesis, we have H1, 4 hypotheses, H2. Okay, let's drag it down until H4. Then relationships. Okay, then beta. Okay, let's find it out from the SmartPLS software. Okay, so now the objective at this point is to test the hypothesis. Okay, and this hypothesis actually is related to our structural model. I mean the inner model. So in the inner model, we have hypothesis, okay, relationships. Then we have a R square. Okay, we have Q square. We have F square. So these are part of the quality criteria. At first, we need to check whether my hypothesis is supported or not initially. So to identify the hypothesis and whether it is significant, we have to run a bootstrapping procedure, right? Bootstrapping. So it should be one tail test, since the direction of hypothesis is one directional. For example, we say the positive, the top management support will have a positive effect on cloud computing adoption. So it's a one directional. So if it is one directional, we should select one tail test. So that's the understanding, right? And everything remains same. Start calculation. So remember, when we want to get the significance level, we have to do bootstrapping, and we need to switch from two tail to one tail depending on the direction of the hypothesis.
Subsample 500 and 5000 একটু
Okay, when you do the bootstrapping, we see there is 500 by default. So their recommendation is we should use 5000, okay, in the final stage. When we are ready to make the report from the results and to put it in our thesis and to put it in the paper finally. So it is recommended to use 5000, not 500. So the question is why we are using 500 now. It is because if we switch from 500 to 5000, computer takes time to run the program. So that's the only difference. So we don't want to wait too much for this kind of calculation right now. But finally, we know that we have to select 5000 minimum. Okay. So now we need to get the path coefficient result and to check whether these are significant or not. Okay. So here we see there's a report from final result about path coefficients, and we can directly copy to the Excel format. Okay, we copied this table, okay, from the software. Okay, and we have got the relationship. So imagine this relationship is related to hypothesis 1. Okay, just for the sake of our discussion. Okay, now we need to have a beta coefficient values, and where we have two beta coefficient values here. One is original sample and another is sample mean. So which one should we take? We should take this one, original sample. Okay, and there is a slight difference between these two. This is from subsamples from they have created, right? So we should not take this one. We should take the original sample. Okay. So the standard deviation is the standard error same. In SmartPLS, the meaning of standard error or the standard deviation is same. Okay. Then we have upper limit and lower limit. What is this one? Okay, let me check. Okay, in the software, we have confidence intervals, 5%, 95%. Copy it to the Excel. Okay. %, 95%. Delete. Okay, now decision about the hypothesis first. Okay, which hypothesis is supported and which one is not supported? This is the basic, the analysis of any paper, that whether my hypothesis is supported or not. Okay, let's make it 3 decimal, all the values. It is suggested by APA format. They have their recent suggestion previously up to 2 digits. Now they recommend for 3 digits. Okay. So the idea is which hypothesis is supported and which one is not supported. So before looking at these values, okay, we have to look back to our hypothesis first. So what was the hypothesis? Okay, for example, complexity and cloud computing adoption. What was the hypothesis? Okay, imagine that hypothesis was negative. Imagine if the complexities become high, the adoption would be low, right? So complexity has a negative impact on cloud computing adoption, for example. So our hypothesis was negative. Imagine. Now we have the beta coefficient, which is 0.48, is a kind of very strong effect, and the t value, the minimum standard or cutoff value is 1.64, and it is more than 1.64, means it is significant. And p value also shows it is very significant. It is less than 0.05. Okay, and the upper limit and lower limit of the confidence interval, okay, it also shows significant. Now the question is, how do we know this figure shows significant? We already have standard of t values and p values. And what is the standard of confidence interval? So the standard is, the reference point is, there should not be a 0 between these 2 values. Okay, let me repeat, there should not be any 0 between 2 values. And we can easily identify by if both the values are positive, then there is no chance of 0 coming in between, right? So if the values both are negative, and also 0 cannot come in between. But if one is positive and another is negative, then 0 actually falls between these, okay, values. So then we would say it is not significant. Okay, if one value shows negative and another one shows positive, means it is not significant. If both are positive and both are negative, it's significant. Okay, so now we see that this value shows less than point. If p value shows significant, t value shows significant, and confidence interval shows significant. So our hypothesis was complexity has a negative effect on cloud computing adoption. Now you tell me, what would be my decision?
Supported.
Supported? It is positive.
Yes, yeah, supported.
Beta value is positive. Okay. My hypothesis was negative.
Negative.
Now beta value is positive. So decision is it is not supported actually.
Not supported.
It's not supported. So that's the decision. You understand? Okay. Let's check another one. We said the top management support has a positive effect on cloud computing adoption. Okay, it was our hypothesis. Has a positive effect on cloud computing adoption. Now the beta value shows positive. Okay, beta value shows positive, and it is also significant in all three criteria. So basically, three criteria is talking about the same thing, significance. So it shows positive, I mean significant. So it is supported. Okay, now let's check the second hypothesis. Perceived risk. Imagine we had a negative hypothesis. I mean, the risk has a negative effect on cloud computing, means the more risk, okay, the more negative. So the hypothesis was negative. If there is a high risk, the adoption would be negative, right? It's a common sense, logical explanation. Okay, so we found the beta coefficient is negative and p value, I mean the t value is more than 1.64. Okay, more than 1.64 means significant. P value is less than 0.05, significant, and these both are negative, also significant. So decision is, imagine that we develop this hypothesis, the complexity has a negative effect on cloud computing adoption. Means if there is more complexities, okay, in handling cloud computing, for example, so adoption would be low. Understand? Low adoption, not high adoption. So complexity, for example, complexity and smartphone use. If it is more complex to use smartphone, the user will say, okay, I will not use the smartphone. Means low adoption of smartphone, right? So here, same thing is a technology. So if it is more complex, the adoption would be low. Okay. So the hypothesis was the complexity has a negative effect on adoption. Okay. Now, after collecting data, we have found that the beta is positive. So this is the first indicator we have to check. Okay, whether the beta is positive or negative. Now, if it is positive, so then the hypothesis is in risk actually. Maybe we have to say not supported. But before saying this, we have to check whether this beta is significant or not. Okay, if it is significant, then we will conclude that yes, we cannot support our hypothesis. Okay, but if it is not significant, okay, if it is not significant, we conclude again that we cannot support the hypothesis if it is not significant. Okay, in the explanation, okay, in the explanation we would say that this relationship, I mean, we didn't find a relationship. Okay, we didn't find a significant relationship. Okay, thereby we cannot support our hypothesis because our hypothesis said positive, I mean negative effect. So we didn't find actually a relationship in that case. But here we found a strong relationship because these three values are significant, very strong relationship. But this is positive and our hypothesis was negative. So we have to take that our decision is not supported. You understand?
Yes, I understood now. Okay, thank you.
Okay, thank you. So Alhamdulillah, we understand. Okay, now BIF. Okay, you understand all the hypothesis, right? Any confusion about the hypothesis? No more confusion. Okay. If there is confusion, inshallah, will I will be there. Just email me, no problem. I will inshallah try to help you. Okay, next we have to identify BIF. BIF. Okay, now let's go to the website. Okay, sorry. Okay, BIF. Now, BIF is related to our algorithm, not bootstrapping. Related to algorithm. Okay, let's say you have run the bootstrapping and you don't have the algorithm in this report panel, so you can close and rerun. Okay, recalculate, no problem. So now the point is, now you see the button are all inactive, right? So if you are here, there's the problem. So then you have to go to the model. Okay, if you go to the model, then the button will be active. Okay, so then you can rerun the algorithm. Okay, we have already have the algorithm result. So from there, under the quality criteria, we have collinearity statistics. Okay, collinearity statistics, BIF. Okay, so in BIF, what is the standard criteria of BIF? So we have to go to the our when to use and how to use BIF, right? You see the collinearity BIF. You remember we are in the page number 15. Okay, this is the table, summarized table. They have given all the reference values. So you should refer at this paper. Also, you can refer to the Joseph Hare book I have given. So now about BIF, probable critical collinearity issue when BIF is higher than 5. Okay, if the BIF is higher than 5, it has a critical issues. There is a serious problem. Possible collinearity issues when BIF higher than 3 but lower than 5. Okay, ideally shows that BIF less than 3. So if the BIF is less than 3, okay, this is a very ideal situation, means our model is very good. But if it is more than 3 but less than 5, but still tolerable, okay, still tolerable. Maybe we have our model may not be so much attractive, but still we have a model. That's the idea. For example, you have a furniture at home, so maybe there are some varnishing problems, but still it is a furniture, right? So that's the idea. So we have an ideal case and we have tolerable case. Okay, now we have outer BIF and we have inner BIF. Which one should we take? Because we are in the inner model, you see, structural model. So we should take inner BIF. So alhamdulillah, all our BIF are less than 3. So we can report this one in the Excel.
But if it is greater than 5, that time how we should report, or what is the remedy?
Okay, that's a good question. If it is more than 5, Okay, what is the problem actually? The problem is, okay, let's take you to the software first. Let me show you what is the problem. Okay, say a BIF is more than 5. So if it is more than 5, it shows that it has a collinearity problem, means the item of this variable is similar with the item of this, some of this construct. Okay, so means although we have established discriminant validity in the measurement model, but in structural model we have also collinearity issue. So in that case, the suggestion is maybe we have to consider for higher order construct. Okay, we have to consider for making a higher order construct. So there's the suggestion they have given in the literature. Or if you think that there is no chance of making a higher order constructs, so then maybe there are problems with the data. In that case, you have to recollect the data by, refining the questionnaire again. Okay, so there's sort of idea they have given.
So if it is 3 to 5, then it is within the range.
Within the range, yeah.
Tolerable.
It's not a problem. It's not a problem. We can still move on to the next stage. Okay, so then R squared. So in the model, we have only one R square, right? So under the quality criteria, under algorithm, under quality criteria, we have R square. So we have R square, one is adjusted and another is the R square. So we should take the R square only, not adjusted R square. So adjusted R square basically is showing if sample increase or decrease, then what would be the change? So it is a kind of imagination. So we are taking the R square from our sample. Okay. Now
So you should select the R square, not the adjusted one.
Yeah. Yes. R square. So there will be a slight difference basically, not significant difference actually.
Sir, can I have a questions for R squared?
Okay, sure.
Sir, is there any minimal threshold for R squared? Minimal value?
Minimum value. Okay, very good question. Thank you. So the idea is if my R square is 0.35, for example, can we say my model is poor? Okay, or model is good, or model is moderate, moderately good. Okay, so the answer is it depends. It depends on the area of studies. Depends on the area of studies. Sometimes some areas, if they have 0.35, this value is very high. For example, in marketing research, okay, normally they don't find large R square. If they have 0.35, they can say, oh, it's a good model. Okay, but in terms of educational research, for example, you have a limited variable that explain your dependent variable. Okay, and you are certain of what are the independent variables. Okay, in that case, you will have a high R square. But when there are so many factors behind one dependent variable, and we have ignored many. Okay, we might have taken so many variables. So the idea is the more very independent variables you have, there is a chance that the R square will be high. Okay, the more R square value it would be if there is more independent variables. So we have not taken so many independent variables. That's why we find a low R square. So you cannot say this R square is very poor. Okay, you just report that the I mean, our 4 factors: complexity, perceived risk, relative advantage, top management support. They explain these 4 variables explain 35% variance, 35% variance of cloud computing adoption. So that's the explanation of R square, okay? And we cannot say it's very poor, okay? Unless, you know, it is less than, you know, 5%, okay, or 10%, okay? In that case, you might have, or you should think about, you know, I mean, putting more factors, I mean, the independent variables in your model to increase the R square. So, but if, you know, in marketing research, 0.2, it is also very moderately good. So there's the, you know, statement given by Joseph Hare in his book. Okay, this is not my statement. So that's the idea. Okay, next, the Q square. Okay, so the Q square. Okay, before Q square, we should take the F square, because F square is given in software already. Okay, so we have F square under Q square. Okay, quality criteria. These are related to the quality criteria. I mean, about the quality of my model. As I said, your quality and some others else quality may not be same, right? But you have presented a model and he also presented a model, no problem. In quality, there might be some differences. Excel format. So let's put it here. Okay. So make sure whether first one is related to complexity or not. Let's check here. Okay, perceive. Okay. So make sure the value are correctly you are putting in place. Okay. Now we see F square. What does it mean? So the meaning is the idea is, let's take you to the model. So say for example, top management, we have, okay, before, I mean, understanding, let's see what are the reference values for F square. Okay, reference value, I mean the standard. At page number 11, okay, as a rule of thumb, the higher than 0.02, 0.15 and 0.35 depict small, medium and large effect size. Okay, so that's the reference value. So it is a small effect, it is medium effect, and it is large effect. So in our model, we have this is large effect, right? This is small effect. Okay, this is moderate effect. Okay, so now what is the explanation actually? We have effect. Okay, unless it is 0, okay, we have effect actually. We cannot say we don't have effect. So the values indicate that complexity individually has the largest effect on cloud computing. Okay, perceived risk individually has this effect. Okay, so why is it related to the path coefficient? Okay, that might be the question. Is it related to the path coefficient? So the answer is no, it is not exactly same of the path coefficient, because effect size, the idea is, the path coefficient, if you combined the 4 variable together and you get the path coefficient here. Okay, let's change this to the model path coefficient. Okay, so this 0.448, that's the path coefficient, and our here the path coefficient is 0.284. Okay, so there's this difference. You see that there is a difference. Okay, the difference is this path coefficient 0.448, it is based on combining 3 variables together. Okay, and we get this path coefficient. But if we delete 3 and just we run complexity and cloud computing, okay, then how much path coefficient we get? So that's the idea of, the individual contribution. Okay, what is the individual contribution of complexity on cloud computing? So that's the actually idea behind the effect size. So it actually gives us an idea about which variable is important and which variable is not so much important. For example, from there we see complexity is very important because it has more individually more contribution, and this one it is the least important factor. Okay, so there's kind of interpretation and explanation we can have from the effect size. Okay, now move on to the last one, Q square. Again, this 3 is part of our quality criteria, quality of the model. Okay, now effect size, from where we get the effect size. Okay, the Q square, sorry, the Q square. So to get the Q square, we have to run again from here, the model, come to the model and calculate the blind folding technique. It's called blind folding technique. Okay, blind folding, start calculation. Okay, so we get the 0.203. Okay, that's the Q square value we get. Okay, total 0.203. Okay, so let's come to the standard references about Q square. Value larger than 0 are meaningful. Values higher than 0.25 and 0.5 depict small, medium, and large. Okay, predictive accuracy of the PLS model means if the value is, say, for example, less than 0.25 but more than 0. Okay, we can say small predictive accuracy or relevance, predictive relevance. Okay, and if it is between 0.25 and 0.5, we can say it's medium relevance. If it is more than 0.5, we can say it has large predictive accuracy or large predictive relevance. Okay, so what does it actually mean? It means that, say for example, this model. So the idea is, so Q square actually, effect size, from effect size and from R square, we found that yes, these 4 variables explain around 35%. Okay, And from F square, we have seen, okay, complexity individually contributes more, okay. Later, we found relatively which one is very important in terms of contribution. And finally, another idea is the Q square. Q square, it says overall, what is the predictive relevance or predictive accuracy of my model is. So this is a kind of another criteria they have suggested based on they call it holdout samples. Based on holdout samples, meaning it's a kind of a time series analysis. You have data of 1 year and you are predicting 1.5 years based on 1 year data. You understand? So you want to see how much accurate your prediction is. So it's a kind of similar issue that based on my data, they hold out some samples, and based on other samples, they predict other samples to see whether it can accurately predict or not. So based on this data, hold out samples, we found that yes, our value is more than, the Q square is more than 0, and the value is 0.205, means is a medium, moderate predictive accuracy. Okay, we have a moderate, not it is not more than 0.50, right? So it is not high predictive accuracy in terms of the suggestion. Okay, we have moderate. So that is the explanation so far we get, okay, from. Okay, let's see what else we have to explain. So this is our standard paper. So far we have reported our measurement model, and then we have reported our structural model. In structural model, at first we have to test our hypothesis, and then we have to report the quality criteria of our model. Okay, that's all about your paper. If your model is very simple. Now, how about this one? How to copy this one? It's very easy. Let's go to the software. Say, for example, you have this one. Okay, just you want to copy this, export as image to clipboard. Okay, and then you paste in a Word file. Okay, paste it here. Okay, you have done it. You have pasted it. Okay, this is how you can copy and paste. Now let's move on to our mediation analysis.
What circumstance we need to show model fit analysis?
Do we need to show any model fit analysis, right?
Yes, sir.
So answer is not recommended. In PLS, it is not recommended to report model fit analysis, but in AMOS it is mandatory. If you use the software AMOS, then it is mandatory. You have to report model fitness. But in PLS, no, it is not necessary. That's why we have seen many papers in PLS that didn't report model fitness. But in our paper, they have reported few model fitness because they have done consistent PLS. You understand? Consistent PLS. So we didn't run consistent PLS. Yeah, our objective is not to confirm theory. Rather, our objective is to explain to identify predictive accuracy, predictive variables, determining factors, explanatory power. These are the objectives we have. I didn't hear.
আমার একটু কনফিউশন সেটা হচ্ছে স্যার কোন মডেলে যদি হাইপোথিসিস এমন থাকে, 5টা হাইপোথিসিস আছে ফর এক্সাম্পল, এমন যদি থাকে কোনটা ডিরেক্টলি মানে মানে ওয়ান সাইডেড, যেটা ওয়ান টেইল, আর কোনটা যদি এমন থাকে যে লাইক সিগনিফিক্যান্টলি রিলেশন আছে কিনা, বা টু টেইল যদি থাকে, হ্যাঁ, সেক্ষেত্রে আমি কি স্টেপিং এর সময় ওয়ান টেইল ও টু টেইল কোন ধরনের ইয়াতে যাব? আর আমাকে একটু টু টেইলের কিছু এক্সাম্পল দিলে একটু ক্লিয়ার হয়।
Two tail. Okay. So the question is, how can we understand the two tail hypothesis? And also, if the same model has two directional and one directional hypothesis, so in that case, how should we run the software? So at first, let's talk about two directional hypothesis. So far we have understood one directional very clearly, alhamdulillah. Now two directional, say for example, here we see another model. Let's talk about written communication skill, organizational communication skill, community of practice, knowledge sharing, and conference attending conferences. Number of conferences attended. Okay. Can you see the model?
Yes, sir.
Okay. So now, say for example, for the sake of discussion, the written communication has a significant relation or significant effect on knowledge sharing. Okay, now when I say the significant effect, so is it one directional or two directional?
Two directional.
Exactly. Means I didn't set the direction. I didn't say either positive or negative. I said only significant effect. So significant effect may be positively significant effect, may be negatively significant effect. So there's the idea. Sometimes, you know, we don't know how to design our hypothesis. So now, depending on the design or the statement, your analysis would be different. Okay, so it is important to understand the directions. So that's the idea of two directional. Okay, second question. If the same model, say for example, first hypothesis is two directional and rest of the hypothesis is one directional, means organizational communication has a positive effect on sharing, knowledge sharing. Community of practice has a positive effect on knowledge sharing. Okay, so then the idea is how to run. Okay, we cannot run two tests at the same time, interestingly, right? So the idea is to get the score or the values of first hypothesis. Okay, so we should set two tails. So after getting the score, okay, then we rerun the model again using one tail. Then we get those another score again. So that's the idea of getting significance value. We have mediation analysis. Okay, so here we have 1, 2, 3 mediation. Okay, for example, the relationship between written communication skill and conference is mediated by knowledge sharing. The relationship between organizational communication and conference is mediated by knowledge sharing. The relationship between community of practice and conference is mediated by knowledge sharing. So we have three mediation hypotheses here we can draw. Okay. So the file name is sharing. Okay. 200 samples. Let's replicate this model in the software. New project. Okay. Mediation. Okay. Mediation analysis. Double click. Data. Knowledge sharing, right? Knowledge sharing. Open. Okay. Is there any major problem? We see one is 66 here, right? Okay, we should, and also 77. You see, we have problem in the data. So again, using Excel, we have to refine the data. Okay, this is my Excel, and this is not important. It's not part of our model. Okay, let's find the maximum. Okay, no need to get the ID. And then sorting, largest to smallest, expand selection. Okay, then see here it is 7. It written 77. It's 6. Definitely, because scale is 1 to 7. Okay, so it should not have more. Okay. Okay, now save it. Okay. Again, comma, separated value, CSV format. Sharing is called it refined. Okay, sharing refined. Okay. Then come to the Excel, the software. Okay, then delete this data. Okay, then import the new one, sharing refined. Okay, sorry, we have problems with that. We haven't removed this column. We have to remove this column. Okay. And then save again. Okay. Now let's draw the model. Which one? Sharing. Full mediation. Where is our? Yeah. Okay, we have conference. This is the dependent variable. We have sharing, mediation variable. Okay, we have written communication, community of practice, that's the model we have, right? Organizational communication, written organizational communication. This one is written communication. Skills. This one common practices. This is knowledge sharing. Okay, this is conference. Okay, so it has a only one item because we ask respondent how many conferences you have attended throughout your lifetime. So that's the idea. So they said, okay, 30, 20, 10, 5. So that's the numerical score we can get. It's an observed variable. So you see, the model has both types of variables. This is latent variables. These are latent variables, and this is the observed variable. Okay, no problem. The model can run. So this is mediating variable, right? Knowledge sharing, and from knowledge sharing we have conference. So okay, let's make it like this. Easy to understand, right?
মিডিয়েশন ইফেক্ট এর জন্য কি স্যার ডাইরেক্ট ইফেক্ট দেখাতে হয় না মানে
Okay, I'm coming. So we have your questions, right? Okay. So as I said, what is the hypothesis I have? If my objective is to test the mediation, whether knowledge sharing can be used as a mediator variable in this relationship, or whether knowledge sharing acts as a mediator, okay, in the model. If the objective is like that, so you can simply test the mediation and report that, okay, we have mediation or we do not have mediation. Means knowledge sharing can be used as a mediator or cannot be used as a mediator. So I have given a paper, reference paper for your understanding. Let's go back to the paper. Let me take you. Mediation. Okay, the Journal of Developing Areas. Okay, Prof. Ramaya. Okay, in his paper, he assessed the mediation. Let me check the mediation. You see, they have modified the TPP theory. Okay, they put attitudes in the middle. Okay, now they want to see whether attitudes is mediated. Sorry, the subjective norm and intention is mediated by attitudes. Okay, they have two hypotheses. Okay, now positive effect mediated by attitudes. Okay, and this is also mediated by attitudes. Okay, so now what is the idea behind introducing mediation? First, why should I introduce mediation? Okay, the idea is, now I'm talking about the theoretical justification. Okay, how can you justify your mediation? The idea is, when we find a relationship, okay, in the previous studies, for example, we find a relationship written communication skill and conference attended. Okay, we find this relationship, and this relationship is kind of weak. Okay, the relationship is weak, but our logic suggests that the relationship should be strong. Okay, relationship should be strong. So now the idea is, maybe there might be an intermediary variable that can strengthen the relationship between written communication skill and number of conferences. So idea is, I mean, the objective is strengthening relationship. Okay, means our mediator will strengthen existing relationship. So existing relationship was written communication skill and conference. That was the previous relationship, and we found this relationship weak. So we decided there might be a mediating variable, and we found knowledge sharing might be a mediator that actually strengthen previous relationship. For example, another example, I'm giving you another example. Suppose there is rain outside, and we expect that people will use umbrella. So raining and using umbrella, there should be a positive correlation, right? But situation is not like this. Sometimes you may find that some people, they are not using umbrella. Okay, they are enjoying the rain. Okay, so now another variable, if you put another variable in the middle, say desire to stay dry. Okay, the persons or individuals desire to stay dry, so they don't want to get wet. So that's the idea. So these people will use umbrella. So there is a chance for this kind of people, the umbrella use will be very high. So now you find a mediator variable that actually strengthen your previous relationship. So that's the idea of mediator variable. So now in our context, we want to see whether our hypothesis is supported or not. I mean, we have three mediating hypotheses, like written communication and conference is mediated by knowledge sharing, and similarly we have two more other hypotheses. Is I support it or not? So now how to test? How to test my hypothesis? So before testing your hypothesis, okay, the idea is before testing your hypothesis, you have to run the algorithm and you have to check your measurement model first, right? You know the basics is always same. So see whether ABE is more than what is ABE? Construct. Okay, here. AB is more than 0.5 and your loadings are more than 0.5, right? So all the loadings are okay. So we don't have any measurement issue right now. So okay, we have, suppose we have established our conversion validity and we have established our discriminant validity. Okay, after that we go to the inner model to test the mediation. Okay, that's the idea. Now we have to do the bootstrap to see the mediation and to see whether the mediation is significant or not. Bootstrap. Okay, so now is it two tail or one tail? It is one tail. Mediation is always one tail. Okay, because directional, one directional. We want to see the strength of the relationship. Okay, one directional. Now okay, we have a final result. Indirect effect. We have specific indirect effect. Okay, right now we are not concerned about the total. We want to see specific indirect effect. And in specific indirect effect, if you see, they have given the relationship. For example, community of practice and conference is mediated by knowledge sharing. Written communication skill and conference is mediated by knowledge sharing, right? This is the specific indirect effect. And the values are significant. And T values also shows more than 1.64. So means the knowledge sharing actually strengthening the existing relationship. Okay, and we found that our all hypotheses are supported. You understand? Any question? ভাই আপনারা কি ঘুমাইতেছেন নাকি? প্রশ্ন আছে? আচ্ছা আচ্ছা আচ্ছা, কোনো আওয়াজ টাওয়াজ তো নাই?
সবাই তো মিউট করা, এজন্য আওয়াজ পাচ্ছেন না আর কি।
আচ্ছা আচ্ছা, না আচ্ছা, এখন এই মেডিয়েশন নিয়ে আমাদের আরো কিছু প্রশ্ন আছে, আমি জানি, আমি আসতেছি সেগুলোতে। তার আগে আমি চাচ্ছি এখানে কোনো প্রশ্ন আছে কিনা। যাই হোক, সমস্যা নেই।
আচ্ছা ঈশা, আমার একটা ইসে ছিল, আমি মাঝখানে বেশ কিছুক্ষণ অ্যাটেন্ড করতে পারি না, বাট তারপরে ওইখানে যতটুকু দেখছি ঈশা বুঝতে পারছি। তো আমার একটা ওই যে ট্রেনিং এর আগে একটা কোশ্চেন ছিল যে মেডিয়েটিং আর মডারেটিং এর মধ্যে তফাৎটা কি, মানে কোনটাকে মেডিয়েটিং বলতেছি কোনটাকে মডারেটিং বলতেছি, ওটা হয়তো পরে বলবেন নাকি?
আচ্ছা পরে বলবো,
বলে ফেলছেন? আচ্ছা ঠিক আছে,
না পরে বলবো, বলি নাই। ওকে, so okay, let's move on and more discussion about the mediation. Okay, so this is a very simple mediation model. Okay, another model. So here we have a direct relationship as well as we have a mediation relationship. Okay, so like ability positively influence or affect loyalty, I mean the customer loyalty, for example. So likability and loyalty is also mediated by satisfaction. Okay, I mean existing relationship, okay, it can be strengthened by putting satisfaction as another variable. Okay, sorry. So now we have previously, there was a suggestion given by Mr. Baron and Kenny in 1986, and he suggested that before testing mediation, we have to test the direct effect, that should be significant. We have to test this relation, that should be significant. We have to test this relation, this should be significant. Okay, after that we can test mediation. That was his suggestion. Okay, but later in 2013 probably, or 2015, Preacher and Hayes, they said no, it is not necessary to test significance, okay, of this relationship before testing mediation. Is meaningless, is unnecessary. They said our objective is to test whether mediation exists or not. So in that case, we put the mediation and test the indirect effects, okay, to see whether mediation exists or not. That is our conclusion. So based on Preacher and Hayes, it is not necessary to test, individual, to see individual significance. Okay, here is now we have another recommendation actually. Some papers, if you wish, you can report about full mediation and partial mediation, full and partial. So the full is if the direct relation becomes insignificant. Okay, for example, let's test this model. Okay, so now you see the direct relation, the likability and loyalty, right? It is insignificant, you understand? It is insignificant. Now, what is the specific indirect effect? Specific indirect effect, it is also insignificant. Okay, in this model, so we don't see any, so that our conclusion is there is no mediation. Okay, at first there is no mediation because the p-value is not significant. Now what about the full mediation or partial mediation? Full mediation would be, imagine full mediation if direct relation is not significant, okay, but your mediation becomes significant. It is called full mediation. Okay, and partial, your direct also significant and your indirect also significant. It's called partial mediation. Okay, so now try to understand it more logically. Our objective is to strengthen relationship, right? Strengthen relationship by mediation. So previously it was significant, means previously it was strong. Now we are making it more strong. So it's called partial. And now come to the full mediation. So previously it was non-significant, means previously its relationship was very poor. It's non-significant, right? No relationship. And after introducing the mediation, it becomes significant. So that's the full mediation. You understand? Okay. So you can report full mediation and also partial mediation if you wish, no problem. So that's the idea behind mediation. So now moderation.
ভাইয়া একটু জানা আছে, আমাদের পি ভ্যালু তো ভাইয়া রেড কালার দেখাচ্ছে।
হ্যাঁ, সিগনিফিকেন্ট না,
আচ্ছা
মানে আমাদের পি ভ্যালু সিগনিফিকেন্ট দেখায় না, মানে হচ্ছে আমাদের এই মডেলে কোনো মেডিয়েশন নাই। আমরা এই যে এক্সপ্লেনেশনটা দিয়েছি এটা ইমাজিনেশনের উপর ভিত্তি করে, ফুল মেডিয়েশন এবং পার্শিয়াল মেডিয়েশন।
তো এটাকে আমরা মানে ধরেন আর্টিকেল যখন করতে গেলাম, আমি যখন মেডিয়েশনের মডেল দাঁড় করালাম, একেবারে অ্যানালাইসিসে গিয়ে যখন দেখতেছি এরকম সিগনিফিকেন্ট হচ্ছে না, তখন কি আমরা এটা কমপ্লিট করব, নাকি ওই অবস্থায় জাস্টিফিকেশন দিয়ে কমপ্লিট করব, নাকি ওখানে থেকে আবার এটা কারেকশন করার কোনো সুযোগ আছে?
কারেকশন দরকার নাই, আপনি বলবেন যে উই ডিডন্ট ফাইন্ড মেডিয়েশন ইন মাই মডেল।
আচ্ছা আচ্ছা, মানে জাস্টিফিকেশন দিয়ে ওটা আমরা শেষ করে দিব ওখানে।
রাইট রাইট, এটা যে মেডিয়েটর হিসাবে পয়দা করে আসতে হবে তা কোনো পথ দরকার নেই।
আচ্ছা আচ্ছা, থ্যাংক ইউ ভাইয়া।
স্যার আমার কোশ্চেন হচ্ছে, এটা তো ধরেন আপনি তিনটা ভেরিয়েবল দিয়ে জাস্ট ছোট একটা পরিসরে এটা দেখাইছেন, হ্যাঁ
রাইট।
আমার মডেলটা যদি আরো বড় থাকে, সেক্ষেত্রে আমি নরমালি তো আমার রিপোর্টিং গুলো করার পরে আমার যেই তিনটা ফ্যাক্টর বা ভেরিয়েবল নিয়ে মিডিয়েশন স্টাডি হবে, পরে আবার ওটাকে আলাদা করে এইভাবে করে আমাকে রান করাইতে হবে
না,
রেস্ট অফ দা ভেরিয়েবল বাদ দিয়ে?
না না, যেমন আমাদের আগের মডেলটা কি ছিল, ওটা তো একটু কমপ্লেক্স ছিল, এখানে মেডিয়েশন কি আছে। ফর এক্সাম্পল আমরা এই একটা ডাইরেক্ট কানেকশন, ওকে, you understand,
Right.
That's the direct connection. So if you wish,
দুইটা বাদ দিতে হবে, রিটেন কমিউনিকেশন এন্ড অর্গানাইজেশন স্কিল?
no, you can draw like this one direct, yeah, okay, you have direct and also mediation. You see, every variable is directly connected to the dependent variable, right, and also is mediated by a mediator.
আমাকে হচ্ছে ডিরেক্ট কানেকশনের আগে একবার বুস্ট্র্যাপিং করতে হবে, তারপর আবার ডিরেক্ট কানেকশনের পরে আরেকবার করে দেখতে হবে যে এটার কি অবস্থা, এরকম?
এটা একটা এই রেজাল্টে পাওয়া যাবে সবকিছু। সিগনিফিকেন্স টেস্ট করার পরে ওখানে রিপোর্টের মধ্যে কিন্তু সব দেয়া থাকে। এখন আমরা সবসময় কিন্তু মেডিয়েটর দেখি না, যেমন আমার মডেলে মেডিয়েটর থাকলে ও কিন্তু অটোমেটিক মেডিয়েটর রেজাল্ট দিয়ে দিবে।
Can you run this model for a little?
Okay, now see, we have a more direct relationship, right? You see, community practice and conference attendance, right? Number of conference attendance, number of conference attendance. You see, direct relationship. You understand? These are direct relation. So you found that it is not significant, okay? For example, and your specific index, say for example, community of practice and a number of conference attendance, okay? These ones, particularly this one, let's focus on this. We found it's not significant, direct relationship. And what about the mediation effect? This one, right? So it is significant, means there is a full mediation. You understand?
এইভাবে করে করে মানে তিনটাতে আমি যেতে হবে আর কি।
Right. So from the same run, okay, you get all these values.
আমি তো ভাবছিলাম যে বিফোর মেডিয়েশনের আগে আমাকে আদার্স গুলো বাদ দিয়ে শুধু আমার যে ইয়াতে মেডিয়েশন স্টাডি আছে ভেরিয়েবল গুলোতে ওটাকে নিয়ে আবার আলাদা করে মডেল রান করতে হবে।
Not necessary, okay. So now we have to move to the moderation. Moderation, job satisfaction and mobility. Okay. So in the moderation folder, I have given two files. I have given two files. One is job satisfaction and another is mobility. And now, you have to check your moderation folder. So now the question is, what is moderation? Okay. Arif bhai ki asche nahi? Now we see a model like we have a job satisfaction and we have a burnout. So the high burnout is kind of job stress. Okay, job stress. So high burnout indicates low job satisfaction. It's a negative impact. Okay. So burnout has a negative effect on job satisfaction. That's the hypothesis. Okay, now we have a moderation hypothesis here. We want to see whether this relationship is moderated by gender. Means we want to see whether this relationship is different for male and female. Okay, I mean, is there any differences between male and female in terms of this relationship? Maybe we want to see, say for example, male has the low impact, okay, and female has high impact. This kind of situation we may want to see. Okay, so the hypothesis is whether gender has any interfere on the relationship. So the idea of moderation is, in previous studies we found a relationship that is burnout and job satisfaction, but this relationship found to be inconsistent. So now we want to justify why it is inconsistent. Maybe some found positive, some found negative, some found strong relationship, some found weak relationship. So based on the previous inconsistency of the result, we are in a position to identify whether any third variable, is there any third party interfering on the relationship. তার মানে তৃতীয় পক্ষ এখানে হস্তক্ষেপ করছে কিনা, এই একটা বিষয় আছে কিনা এখানে। So from that understanding, we found that gender might be one kind of variable that actually may have interference on the relationship. So now we want to replicate this model in the SmartPLS. So we want to create a project, mod variable, okay, double click, job set categorical variable. This is categorical variable because our moderator is gender. So gender is a categorical variable. We have 0, 1 or 1, 2. Okay. If it is male, say for example, it is 1. If it is female, it is 2. Right? This sort of, values we have is called categorical variable. Okay. For example, gender we see the maximum is 1, right? So minimum 0 means 0, 1. Okay. So gender is categorized by 0, 1. Okay. Say for example, 0 means female and 1 means male. Okay. No problem. Moderator. Let's draw the figure. We have burnout. We have job satisfaction. We have gender. Okay, now try to write alignment. Bottom. This is burnout. This is job satisfaction. This is gender. Now we need to connect it to the dependent variable. Okay, the gender. So to run the model, we need to connect it to the dependent variable. So, and now we have to create the moderator variable. How can we create? Right click, add a moderating effect, or you can click here. You have moderating effect over there. No problem. You can go right click and then here another click. So job satisfaction is our dependent variable by default. And what is our independent variable? Is burnout, right? And then moderator variable is called gender. Okay. And now we have 3 calculation methods: product indicator, 2-stage orthogonalization. So it is better to use 2-stage always, because you can use product indicator if the model is reflective. Okay, if the model is reflective. So if there is any formative construct in the model, okay, if there is any formative construct, then you have to switch to 2-stage. Okay, now the 2-stage works perfectly for all types of models. So that's why it is in default stage. And our model is reflective. Okay, so far all the constructs are reflective, so we can use product indicator, no problem. Understand? So that's the idea. So okay, and keep other things unchanged. So here we can rename moderating effect, no problem. You can keep it existing as it is, or you can rename it. Okay, so we keep it as it is, moderating effect. So, but if you have more variables, then it is difficult to identify what is the effect. I mean, what is the interaction. So in that case, you can rename to identify the interaction. For example, here the interaction is burnout into gender. So that's the interaction. Okay. So it has hidden the indicators. Show indicators of selected constructs. So you see, it has shown that it actually multiply this latent variable and this latent variable, no problem. You can hide it. Okay. And what is latent variable? Latent variable actually, it has a score based on the items. So it has a score. I mean, the gender has a score. We call it latent variable score. For example, job satisfaction has a score. Call it latent variable. Okay, score. Okay, now the interaction. We want to see whether the gender has effect. I mean, whether gender actually moderates their relationship between burnout and job satisfaction. So again, it is testing moderation is part of your inner model. So before inner model, you have to check whether loadings are okay or not. So algorithm, you have to check whether there is any problem with the loadings. Okay, for example, we find one problem here and another problem is there. Okay, so better to delete this one and also delete this one. Very poor. Okay, then rerun again to see any problem. Okay, so far no problem, so far no problem. Okay, that's good. So we have established our measurement model, and also you have to check the report, right? Okay, what is the report? Yeah. So also we have to check the validity, reliability, discriminant validity, all those stuff you have to check. Okay, suppose we have established our measurement model, and then we come into inner model, that is structural model. And in structural model, we have to test our hypothesis, and our hypothesis is whether gender moderates the relationship between burnout and job satisfaction, right? That's the objective. So now to see whether gender moderates, we have to check the significance, right? Bootstrap. Okay, now it is two-tailed because interaction, we don't have the directional effect. Okay, so either positive or either negative, we are not certain. So moderation always two-tailed. Okay, so now see the interaction. This is our interaction. Okay, and we see that beta coefficient is 0.16 and it is significant. T value is more than 1.94. Okay, two-tailed, that should be 1.94 and it is also significant. Okay, so now confidence interval. In confidence interval, we see yes, there is no zero between these two. So in 3 criteria, we have established that we found our moderation is significant. So the conclusion is our hypothesis is supported, and once our hypothesis is supported of moderation, then we have to show for more clarity what is the level of interaction. Okay, what is the level of interaction? Okay, let's see. We have given papers.
আমরা এখানে এবি দেখি নাই কেন?
Yeah, of course সবগুলা দেখতে হবে। মানে মেজারমেন্ট মডেল এস্টাবলিশ করার পর আপনি স্ট্রাকচারাল মডেলের যা যা আছে এগুলো কিন্তু সবই বলবৎ থাকবে। আমি কিন্তু আবার ব্যাক করছি না একদম A to Z থেকে।
না না ব্যাক করতে হবে না ভাই, এমনি জিজ্ঞেস করতেছি ওই যে আমরা যখন ওই ডিসক্রিমিনেট সরি কনভার্জেন্টটা করছি মেজারমেন্ট মডেল করার আগে ওই দুইটা ডিলিট করলাম, আইটেম ডিলিট করলাম, লোডিং যেটা কম ছিল, তো ওটা ডিলিট করার পর আমরা এবি আর দেখি নাই, আমরা পরের স্টেপে চলে গেছি। ওখানে কি এবি দেখার দরকার আছে?
অবশ্যই অবশ্যই দেখার দরকার আছে।
দরকার আছে। আচ্ছা
স্যার এখানে আমি একটা জিনিস একটু ক্লিয়ার হতে চাচ্ছি, সেটা হচ্ছে স্যার আপনি তো প্রত্যেকটা জিনিস আলাদা আলাদা মডেল দিয়ে করে করে দেখাচ্ছেন। হ্যাঁ, যখন আমরা কোন একটা পেপারে কাজ করব, একটা পেপারে যখন একটা মডেলে বোথ ডিরেক্ট, মিডিয়েশন, মডারেশন সবগুলো যখন থাকবে, তখন তো আমরা শুরু থেকে একবারই করবো না স্যার এগুলা, নাকি আবার আলাদা আলাদা করে ডিরেক্ট ইফেক্ট, দেন মিডিয়েশন, আবার দেন মডারেশন এভাবে যাব, নাকি একসাথে রান হবে? ওখানে
শুরুতেই আপনি মেজারমেন্ট মডেল পুরোটা একসাথে তো অ্যাসেস করবেন।
করা হয়ে গেছে, জি রাইট, দেখার দরকার নেই,
আর দেখার দরকার নেই, রাইট।
আমি শুরুতে তো মেজারমেন্ট এবং স্ট্রাকচারাল সবই তো দেখে ফেলছি, তো আমাদের পিছনে আসার দরকার নেই।
না না, পিছনে আসার দরকার নেই, রাইট রাইট। আমরা যেহেতু এটাকে একটা নতুন মডেল ধরলাম, এই জন্য আমাদের দেখতে হচ্ছে।
অর্থাৎ স্যার আমি একটা মডেলের মধ্যে ইন্টিগ্রেটেড ওয়েতে সমস্ত কিছু একসাথে মানে স্যাম এমএ বের করতে পারি, এটাই তো?
রাইট রাইট। So I have given an Excel template in the moderator folder, and one is categorical and another is for continuous variable. And this one, since our moderator variable is categorical, we have opened the categorical moderator Excel file. Okay. Now, okay, let's browse little bit in the left side. Sometimes we go to the right. We don't see the values here. Okay, this is the default setting. So now we have to bring some changes in this area. Name of the dependent variable, name of the moderator variable, name of the moderator values. Okay, say our 0 means what? 0 1, right? 0 means female, for example. Okay, and 1 means male, and name of the independent variable, it is burnout, right? Burnout. So burnout. Okay, then regression coefficient. So beta coefficient, we have to check what is the beta coefficient. So in the report, we have path coefficient in this table, right? Let's see the okay, let's copy this one, okay, for the time being. Okay, and do not type below this line. Okay, it's red mark. Let's put it. You have to delete this one, okay, immediately after that. So the value, they said dependent variable. Our dependent variable is burnout. This is this one. Beta coefficient. Okay. Then moderator, gender, this one. This one. Then interaction, this one. Okay. So now we see, okay, let's delete this one. You see, we have provided 3 values and we are not putting anything in this area. Keep it unchanged. Okay, let's keep it unchanged. Do not touch this one. Okay. So we see a dotted line and also a solid line. And in here, it is called dependent variable. You can rename this dependent variable. Okay, our dependent variable is a job satisfaction. Okay, you can rename it. So then we have burnout. This is our independent variable, and there are 2 categories. I mean, the system divided burnout into 2. One is low burnout and it is high burnout. Okay, and think about the relationship regarding a male. Okay, regarding male, you see, when burnout is low, okay, I mean when burnout is at this stage, for example, okay, okay, when burnout is in this stage, okay, then job satisfaction drops relatively less than the female. Okay, you see, for female it sharply drops the, I mean, job satisfaction. Dependent variable is our job satisfaction, right? So for high burnout, okay, the female reacted more than the male. So that's the understanding from this graph. So you understand the, I mean, graph? Okay, you know, this is our job satisfaction and this is burnout. Okay, so job satisfaction, this is low job satisfaction at this stage and this is high job satisfaction, right? Okay, now for the people who have low burnout, for example, think about the male, male, low burnout. Okay, so low burnout means satisfaction would be high, right? Common sense. I mean, low job stress. Okay, so there, when the burnout increases, okay, when the burnout increases means when the burnout becomes high, their job satisfaction also drops, but not as like as the female. Okay, for female it sharply drops compared to the male. That's the idea, right? Now it's clear, I think. Okay, so you can think about more after this session, no problem, and also you can read some papers, okay, to get more understanding. So we have another a model to run on the same topic. This is, we have another continuous variable. Okay, continuous, we have mobility. Let me show the mobility. Okay, this one is also a moderator model. We have employability and mobility. Okay, employability and mobility. So does the relationship between employability and mobility is moderated by work-life balance. Okay. Now, what is employability? Employability means, I think I have given a paper, okay, for this one. Okay, let me show. Yeah, this one. I have given this paper inside the moderator folder. Okay. Employability and mobility. So employability means that you have the employability skills. Okay, to get the employment, you have more skills. The more skills or the more ability of employment you have, the more chance you will switch from one company to another company. Means your mobility would be high. Okay, so you are switching from company to company. So there's the idea. Employability, high employability will have a positive effect on mobility. Okay. Now they want to see whether work-life balance means some people can balance their work and life, means jobs and family, right? So we talk about work-life balance. So if people has good work-life balance, we want to see whether this thing actually moderates this relationship or not. Okay, that's the model. Okay, let me take you to the model again. Okay, this is the model. Now we want to replicate the model in SmartPLS. So we have to create a new project, mod categorical, mod cat দিয়ে আমরা একটা সেভ করলাম, double click. So it is continuous. Okay, this is continuous, not categorical. This is continuous. So okay, let's draw the model. Employability, we have many items. We have mobility, we have work-life balance. So this is independent variable. Employability means ability to get employment, and we have here dependent variable, which is mobility, means moving from one company to another company. So it talk about the frequencies, right? Whether they want to move or not. And work-life balance. Work-life balance. Okay, means balance between job and family. Okay, so connect. Now we have another moderator. Right click, add moderating effect, dependent variable mobility, moderator variable, work-life balance, independent variable, employability, 2 stage, and okay. So keep it as it is, no problem. Now again, this is this new model. We have to establish our measurement model first to see is there any problem in the loadings. Outer loadings, okay, any red marks? No red mark, sorry. Yes, red marks. Okay, we have problem with the work-life balance. Yeah, these two items, right? First, we delete the lowest one. Let's see whether it improved little bit or not. If not, then we have to delete the second one also. Then, okay, no problem. It is less than 0.5. Okay.
How many items we should keep at least? মানে আমরা যখন কোশ্চেনটা ডেভেলপ করব, ধরুন এখানে এমপ্লয়েবিলিটিতে প্রায় 10টা আইটেম দেখা যাচ্ছে, হ্যাঁ। সো এখানে আমার এটা আমি রিস্ক ফ্রি যে আমার দুইটা বা তিনটা আইটেম যদি 0.5 এর নিচে আসে আমি ডিলিট করতে পারি।
আপনি ইয়েও করতে পারেন, যে 0.5 এর উপরে গেছে, 6 এর নিচে আছে, এগুলো আপনি দিতে পারেন ডিলিট করে, কারণ এখানে অনেক আইটেম।
কিন্তু আমার যদি ধরেন 3টা বা 4টা এরকম থাকে তাহলে একটু রিস্ক না নাকি?
হ্যাঁ হ্যাঁ, তা তো অবশ্যই রয়েছে। আপনি আছে 3টা, আপনি 3টে ডিলিট করে দিন।
এখন স্যার ধরেন 3টার মধ্যে থেকে একটাতে আসছে 0.5 এর নিচে, তাহলে একটা তো ডিলিট করাই যায়, 2টা থাকে।
রাইট, একটা করা যাবে, রাইট।
কিন্তু 2টা নিলে তো স্যার সম্ভব না, ঠিক না?
রাইট রাইট রাইট, তখন এটা ভ্যালিডিটি নিয়ে প্রশ্ন দেখা দেবে।
ওই জন্য স্যার আমাদের অ্যাটলিস্ট 3টার নিচে আসলে আইটেম রাখা উচিত না।
এবং সাধারণত আমরা 3টার নিচে আইটেম পাই না, যারা ভালো ভালো মডেল স্কেল ডেভেলপ করে, ম্যাক্সিমাম মোর দেন 3। ওকে, significance to see whether moderation is significant or not. Bootstrap. Okay, to see the interaction, moderating effect. Yeah, it is significant. Okay, p-value and p-value shows significant. So now, if it is significant, the next step is we have to check the interaction, I mean level of interaction using the plot. So now open the second plot, moderator continuous, in the Excel. Moderator continuous.
তো এখানে যে লাস্টে যেটা ইনসিগনিফিকেন্ট আসছে, এটা তো আমার মডারেশন ইফেক্টে তো ইমপ্যাক্ট করবে না।
না না না, ওটা নিয়ে আমরা ভাবছি না। আমাদের হাইপোথিসিস হচ্ছে এখন যে এটা মডারেটর কিনা সেটা দেখে,
ওটা নিয়ে আমরা কাজ করব।
রাইট রাইট রাইট। So the idea is we have to test our hypothesis. Our hypothesis is moderator relationship is moderated by work-life balance. So now we have found that it is significant. So once it is significant, then we have to go to the plot. And remember that if the relationship found to be non-significant, so there is no need to come to this plot. We end the discussion that by saying that our moderator is not significant, means there is no moderation in the model, or work-life balance cannot be, we didn't find work-life balance as a moderator in our model or in our case. So this is how we can interpret. So but if
ক্ষেত্রে কি মডেলটা দেখাতে হবে, বক্সটা দেখাতে হবে আমাকে, বা আমাকে রিপোর্টিং সিস্টেমটা কিভাবে করব?
রাইট, রিপোর্টিং সিস্টেমটা আমরা ওখানে একটা পেপার দিয়েছি, হ্যাঁ, এই পেপারের মধ্যে আছে। So for example, this paper, if you go bottom of this paper, you see that they have done the same thing: employability, mobility, work-life balance, right? There's the interaction. So they have found a interaction, and now we have to draw the plot. So the idea is once we find the significance, then we come to the plot, otherwise not. Okay, so now come to the plot, and you can learn all reporting from this paper. Sorry. Okay, so just I copy this information and come to our continuous moderation Excel file. Okay, here again the same, you just put the information like your moderation, first one. Okay, this is the employability, independent values. Okay, then you have moderating effect, this is the interaction, and then you have a work-life balance, this is the moderator variable. Okay, so now name of the dependent variable, sorry, independent, we call it employability. Name of the moderator is work-life balance, work-life balance. Okay, we put it abbreviation. Low employability, high employability, work-life balance. You see, so here is similar to the previous one. We see we have divided the independent variable into two sections. One is low employability, another is high employability. Okay, and we have here work-life balance. For example, the dotted line, it shows that high work-life balance, and the solid straight line, it shows the low work-life balance. Okay, now the dependent variable is mobility, ability to switch from company to company, mobility, right? So the idea is we found significant. Now we want to see what is the level of interaction. Means we have found significant. Now we have to explain how it moderates. For example, here the people who has low employability, think about this one, the straight line. The people who has low employability, their mobility is straight, means kind of no relation. For them, it's straight. But people with high work-life balance, okay, people with high work-life balance means those who can manage perfectly their job and their family. So for them, if the employability is low, okay, so their mobility is here, okay, at this point, okay, between 3 and 2.5. But if their employability is high, they switch very quickly compared to the people, those who have low work-life balance. You understand? Okay, let me repeat again. Okay, for people with high work-life balance, if their mobility increase, if their employability increases, their mobility also increases. Okay, so there's the understanding of moderation here. So now our time is very limited. Actually, we need to discuss a bit about the differences between moderation and mediation. What is the difference between moderation and mediation? So in the literature, sometimes we see it is very difficult to understand the differences, because same variable can be used either as mediator or can be used as moderator. For example, I think about a relationship between attitudes and intention to buy an apartment. Okay, so attitudes leads to the intention to buy an apartment. So if we bring access to money, for example, okay, access to money, now is it moderator or mediator? Access to money. So previously the relationship might be weak, but if we bring access to money in between, the relationship might be strengthened, because people having access to money, they want to buy an apartment, right? So that is, their attitudes leads to the access to money, then that leads to the intention to buy an apartment. So again, the same variable can be used as moderator to see whether people having more money, relationship is something different, or people having less money, less access to money, maybe relationship might be different. So this kind of situation is very common in the literature. That's why we see sometimes same variable, they have in the same paper, they have tested in two ways, mediation and moderation. But there are certain variable, this is very common to use as mediator. For example, age and gender. You will find this very common variable. They are used as a moderator. So that's the actually idea. So now again, if you understand the concept, moderation is an interaction. Okay, it interfere in the relationship, and mediation, its objective is to strengthen existing relationship. Okay, this is the broad concept. So if you keep this concept in your mind, then you can, I think, inshallah, identify which one would be moderator and which one would be mediation. So let's move on to our formative analysis. So we have very limited time. Okay, formative.
মডারেটর হিসেবে আমরা নরমালি ক্যাটাগরিক্যাল ভেরিয়েবলই বেশি ইউজ করি, নাকি নরমালি ব্যাপারে তো মনে হয় এটাই দেখা যাবে।
Yeah, categorical, yes.
কন্টিনিউয়াসটা মনে হয় ওরকম না, নাকি?
Yeah, we have continuous also, but most of the cases you will find, age, gender,
income.
Yeah. Now the formative, right? Okay, can you see the life stress model, life stress smartphone? Okay.
Yes. Yeah.
Okay, thank you. So here life stress is formatively developed. How do we understand? Because the items, the arrows coming from items to the construct, right? And it is reflective. Smartphone addiction, life stress and smartphone addiction. So here smartphone addiction is reflectively formed and it is formatively formed. Okay, so now how to test the measurement model of formative construct. Before coming to the hypothesis, we have to establish our formative construct. Okay, so now the life stress, think about S1, 2, 3, all are important, question to form the construct of life stress means each one is important. We cannot delete, okay, unless we have strong justification. Okay, so we want to replicate this model through PLS software. Okay, let's come to the PLS. Smartphone addiction, right? 1 to 6. So now what is the procedure? Let's go to our paper, when and how to report, right? When to use and how to report. Formative, reflective measurement model, then formative measurement model. Okay, they have given guidelines for formative measurement model. Okay, formative measurement model is a bit complex. Okay, first they have suggested that we need to study the convergent validity of the formative measurement model. And what does it mean? It means is a kind of redundancy analysis. Redundancy analysis means, say for example, and its correlation should be more than 0.7. Keep it in your mind, correlation should be more than 0.7. Okay, let's go to the software. Okay, so you see our model is here it is reflective, and here still it is reflective, and we need to make it formative. Then how to make it formative? Right click and switch between formative and reflective. Then it becomes formative. Okay, right click and make it formative. So now they suggested that before collecting data, you have to think about that you are going to use this one as formative. So you have to collect a global item question. You have to place a global question in the questionnaire. For example, this is your life stress, right? It is your life stress, and this one is your a smartphone addiction. Okay, before coming to this relationship, they suggested that you have to delete this one first. Okay, they said you have to collect another question that actually represent overall life stress. Means you have another question, only one question. You ask respondent, rate about your overall life stress. Means one question actually representing the entire construct. Okay, although it has limitations, that's why we don't use one item scale normally. But if it is formative, they suggested primarily you have to test the relationship of this construct with a global item. So here we have a global item. It representing the life stress. We have asked our respondent about overall, life stress. Overall life stress. Okay, this is called global item. So this
ফরমেটিভটা কেন করি মূলত?
ফরমেটিভ নিয়ে তো আলোচনা অনেক করলাম, তারপর আবার বলছি যখন আমরা দেখি এটা আইটেমগুলি ইম্পর্টেন্ট, আমরা কোনো আইটেম পার্টিকুলার ডিলিট করতে পারছি না। আমাদের এখানে যখন রিফ্লেক্টিভ ছিল তখন লোডিং ইনকনসিস্টেন্ট দেখাচ্ছিল, কোনটা অনেক কম আসছে, কোনটা অনেক বেশি আসছে। যখন আমি লোডিং ডিলিট করতে গেলাম তখন দেখলাম যে এই কোয়েশ্চেনটা ইজ ভেরি ইম্পর্টেন্ট টু দিস কনস্ট্রাক্ট, সো আই ক্যানট ডিলিট। ওকে, So then I thought about maybe we have to retain all the construct, even if the loading is low, then how to justify? So make it formatively. So in formative, you don't bother about the loadings, okay? So you are more, you have to justify it through theoretically and from literature. Okay, now
আমি তো ডেটাটা তো কালেক্ট করে অলরেডি ইনপুট দিয়ে দেন বুঝতে পারলাম যে এখানে আমার লোডিংস এর আছে, কিন্তু আমি কোশ্চেনিয়ার যখন আমি শুরু করব, মানে আমার স্টাডি শুরু করার আগে আপনি একটু আগে বললেন যে আমাকে এটা আগে সিলেক্ট করে ফেলতে হবে যে ইজ ইট ফরমেটিভ অর রিফ্লেক্টিভ। তো এটা যদি ফরমেটিভ হয় সেক্ষেত্রে আমি তো লোডিংস গুলো বা এটার ইম্পর্টেন্স লেভেলটা তো শুরু থেকে কিভাবে বুঝতে পারি বা
okay, this is a very genuine question. So idea is, yes, we have to go for another stage of data collection. Okay, so that's why it's not easy to use
pilot survey is essential here, or
okay, you can right, you can collect pilot study. Okay, do conduct pilot study, take sample like 100 or less than 100 and check is there any problem. Okay, and after that you have to put this question into the questionnaire again, understand? So now we have to test this relationship first. It's called redundancy analysis. So now if the path coefficient is more than 0.7, then we can use life stress as a formative rule. Okay, is more than 0.75, so means we have passed and we can think about life stress as a formative construct. So this is the preliminary understanding they have given. Okay, so then you can save it. Okay, then you can
গ্লোবাল যে মানে আপনি এখানে ওভারঅল লাইফ স্টেজ যেটা দিয়েছেন ওটার কি ডাটা কালেকশনে ছিল?
yes,
মানে আমি যদি লাইফ স্টেজ এবং ওয়ার্কেবিলিটি মানে এভাবে করি, ওয়ার্ক লাইফ এটা করি, ওখানে আমার কি ওভারঅল ডাটাও লাগবে? এই তো
yes, I mean you have to put the global item in the questionnaire.
আচ্ছা,
Okay, so now this is smartphone addiction. Okay, it is reflective. Okay, so now what is the suggestion next? Let's go back to the suggestion. Okay, we have passed this criteria. Okay, now we have to see the collinearity BIF. If BIF is less than 5, I mean the same criteria. Okay, we talked about BIF previously, also same criteria. You have to follow this one for the formative model here. Okay, so now calculate algorithm. Okay, so now let's see the collinearity BIF. Okay, so now here is inner or outer. Let's think about our model. We have to check the BIF of 4 items. Previously we have seen BIF for our inner model, understand? So now since it is formatively formed, so these values, you remember, it's not loadings, it's regression weights. is much related to the beta coefficient. So since it is regression, so we have to study the collinearity issues, and is there any correlation between these items? So how to identify? By VIF. So the VIF shows, I mean, the all are less than 5. So we have passed our VIF test. Okay, next. So we have reported that, sorry, this is VIF is okay. And then we have to check the significance of the weights. Okay, significance of the weights. Okay, now for significance, always we have to run the both step. Fourth step. Okay. Okay, here latent variable means job, I mean smartphone addiction. Okay, remember this one. It is dependent variable. So the significant, I mean, who is significant? Our regression weights, right? So here, outer weights. Final result, we have outer weights. You see, outer weights. So take a look about the first 4. We found a problem in the LS4. Okay, so copy this one and come to the Excel. Okay, in the Excel, just paste it here. Okay, this is not necessary because this is reflective. So we have we keep it original sample. Okay, and delete this one. We have T statistics P values. We found a problem in this model. Okay, I mean with this one, just put it red mark. So the idea is the software suggests to delete this one. Okay, software suggests to delete this one since it is non-significant. So we know the informative construct, each of the item is very important. So it is highly recommended to keep or retain all the items. Okay, it is highly recommended, but software suggests here that it is non-significant, so maybe you have to delete this one. So before deleting, they have given another suggestion. Okay, in the book, in the paper, they suggested that after that you see the loadings of this item. So now go back to the software. They said, okay, check the loadings, outer loadings. Okay, outer loadings of this, paper. Okay, Excel format. Okay, we copy it in Excel and we go back to the Excel and put it here. Delete. So we do not need, so okay, it is okay. Let's give this one. This is loadings. Okay. Okay. So now they say if this one is more than 0.5, okay, is more than 0.5, then retain. this item. But if it is less than 0.5, okay, then you have to delete this item. So there's the suggestion. So we found that the loading also less than 0.5. So we have to keep it red mark also here. So we tried to retain, but as per the suggestion, okay, given we cannot retain this item. So this is how we justify the keeping or deleting items. So now come to the software. Okay. So this one we have to delete. Okay. So we have 3 items. It is formatively formed, and we have here our 4 reflective items. So okay, rename this one. Addiction. Then what is the hypothesis? You run. Okay. Now come to the structural model. You bootstrap. You calculate. Okay. So then see the path coefficient. Okay, it is significant. Okay, this is how you test your hypothesis. And regarding the reporting, how do you report formative constructs items? I have given one paper regarding reporting. In terms of loadings in formative construct, you will not report loadings, you will report only the weights. Okay, let me take you to the paper. Brain IT. So I have given a paper on information and management on brain information system. Okay, they have a formative construct, and they have reported their construct like this way. Table 3. Okay, table 3. Okay. Okay, table 3. You'll see this is the items. This is the scale type. Is it reflective or formative? And they have put loadings weights together. Okay, if it is reflective, the value is loadings. If it is formative, the values are weights, regression weights. And for AVE, there is no AVE or CR. Okay, for formative construct. Okay, there is no AVE or CR. Okay, at the bottom, you can put a note. What is reflective and formative? Okay, and CR composite, the abbreviation. And if you delete any item, so please left a note at the end of the table. What are the items you have deleted and why? Okay, so that readers can understand. So I think this paper also will help you a lot to understand the formative construct. So, but so far I know they haven't studied the redundancy analysis that we have reported at the beginning, because it is 2013. So redundancy analysis they have suggested later on that for formative construct you have to suggest you have to report redundancy using a global item. So this is all about, I think, our discussion so far. We have talked about formative, we have talked about reflective, mediation, moderation, right?